And so now if you have a trinomial where the leading coefficient is not a 1, and now you have a separate case. There's two ways to solve this. The first way is probably the way that you guys were taught, which is trial and error, right? You can just kind of reverse FOIL, see which ones fit the pattern. And so what you would do to reverse FOIL which is just trial and error, is you just look to see. You know that the two first terms of your factors have to give you a product of 4x squared. So your only options are x and 4x, right? So that pair would give you a 4x squared. Or you could say 2x and 2x. Those are the only two ways that you can get 4x squared. And now your last terms, again, when you're looking at the FOIL, so there's your f's. Your f's have to give you a product of 4x squared. Well, now you look at your lasts. Your last has to be a product of positive 6. So what we would then do is look to see what are the different combinations that would give you a positive 6 and a sum that's negative. So the positive product means the signs are the same, right? They're either both positive or both negative. The fact that the sum is negative means that we know that this sign has to be a negative in between these. And so we're looking for the values, the factors of 6. So we have 1 and 6, 6 and 1. We have 2 and 3, or 3 and 2. And so those are the different possible combinations that will give you a product of positive 6 for your last. And so then what you would do by trial and error, you'd look to see if you took the outer plus inner products, which of these is going to equal negative 11x. And you just test it. So you could say 6x, or a negative 6x minus 4x. Does that give you negative 11x? No. What about now you move to the next one? So now we would be testing this set. So x times negative 1 is negative x minus 24x. Does that give you negative 11x? No. So you can eliminate that one as well. So let's go to the next one. So here's a negative 3x minus a 4x. Does that give you minus 3x and then a minus 8x. Sorry, does that give you a negative 11x? Yeah. So that one works. So your factors for this are going to be x minus 2 and 4x minus 3. Now, if that didn't work, we'd go all the way down to 3. If none of those worked, then we'd start working from the 2x as your leading term. Now, how many of you learned factoring that way? Just trial and error, you kind of find, and it's a mental calculation of what combinations. You can see right here, if 2x minus 3 and 2x minus 2 happen to be the factors, we would have had to have tried 8 different combinations to get it. And now, sometimes trial and error works, and I'll talk about when it's the most efficient way. But there's another method that you can use for this that always gives you the right answer the first time you work through it. It just takes a little bit of organization on it. And that method is called rewriting the middle term. And it's based on what we did with the factor by grouping stuff. All right, if you want to come up with the answer, if trial and error looks like it's going to be testing more than 3 or so different combinations, 3 or 4 different combinations, then you might want to consider rewriting the middle term. And the way that you do that is you follow this process. You take your leading coefficient times your constant. Okay, so what is 4x squared times a positive 6? 24. Okay, when you take that product, you look to see, are there 2 factors of this product whose sum is this middle term? What 2 factors of 24 give you a sum of negative 11? Negative 3 and negative 8, right? Okay, so if you rewrite the middle term as negative 3x minus 8x, do you still have negative 11x? Yeah, you haven't changed the value, only the form. So if you drop the first term down, 4x squared, drop the last term down, 6. Yeah, Thomas? Take the product of the leading coefficient times the constant. Okay, so if you take this product, okay, and then you split that middle term, what we can now do is factor by grouping like we did in that first concept that we talked about. In this first pair of terms, what common factor can you remove? An x, and that leaves a 4x minus 3. In the second pair of terms, what common factor can you remove? 2, and that leaves a 4x minus 3. So of these, your common factor of 4x minus 3 is removed, and what terms are left to make up your other factor? X minus 2. And so you get your answer without having to go through a whole bunch of different trial and error in order to see does this or doesn't this work. Does that kind of make sense how that process worked out? Okay, so we're still this whole thing is still based on foiling. All we're doing though is we're rewriting this middle term so that it's the outer plus inner products. And then we're just working kind of backwards, factoring it out. Okay. So let's take a look at another example of this. And let's say I ask you to factor 5x squared minus 13x minus 6. And now, how many factors does the leading term have? It's just 1 times 5, right? So there's only going to be one combination for the first. So like if you're trying to decide, is trial and error, the reverse foiling, a good method? Okay, so the only terms that you know the first terms are x and 5x. Okay, what about negative 6? What are the different possibilities to give you a product of negative 6? Right, so it's negative 1 and positive 6. Now you can switch the signs, right? And then you have 6, or a negative 6, and a positive 1, positive 6, and a negative 1. And now you have the 2's and 3's, right? So once again, this is, you know it's going to possibly be a lot of different combinations that you would have to test. So let's see if we can rewrite the middle term more efficiently. What's the product of our leading coefficient and our constant? Are there two factors of negative 30 whose sum is negative 13? Okay, now careful. So if you say 10 and 3, okay, now think about the signs of them. The signs have to be opposite, right, because the product's negative. Is 10, a negative 10 plus a positive 3 going to give you negative 13? No, so you need to test negative 15 and positive 2. Okay, so what if we rewrite this middle term as negative 15x plus 2x, drop the first term down, drop the last term down, and factor by grouping? If we factor by grouping, what common factor can we remove from the first pair? 5x, and that leaves an x minus 3. Now from the second pair, what can we remove? 2, and that leaves an x minus 3. So it's going to work for us. We take out our common factor of x minus 3. That leaves 5x plus 2. And there are the factors. Okay, now if you look up here, we would have tested all 4 of these and still not gotten the right answer, because we see what our answer is going to be here.